The definition of scientific notation. Scientific notation: a number written in the form of a times 10 raised to power n, where 1 is less than or equal to a is less than 10 and n is an integer, is called scientific notation. The explanation of this scientific notation is that when we write a number in the form of scientific notation, this is the representation of scientific notation. Means when we write any number in the form of scientific notation, we follow this rule: a times 10 raised to power n. Now this rule has two parts. First part is a and the second part is 10 raised to power n. So a is called any constant number and 10 raised to power n, this is any number where n is any integer. This n contains any number which is a positive number or which can be a negative number. It can be a positive number, it can be a negative number, but this number always contain 10 raised to power. Either it is a positive or negative, but it strictly contain to the power of 10. Now we have to talk about this a, this coefficient number. This a is called the coefficient of this 10 raised to power n. 10 cannot be changed in this scientific notation. In scientific notation, each and every number must be written in the form of 10 raised to power any power, 10 raised to any power. So 10 cannot be changed in scientific notation. That's why I am again and again telling that a is the coefficient. A is any constant number, a is the coefficient of this 10. 10 means when we have to say that any number is the coefficient of the other one, because this is a variable. So 10 cannot be changed in this scientific notation. That's why 10 is called variable. This is a constant number, it's a fact, but 10 cannot change in this notation. That's why we have to say that a is the coefficient of 10. Now we have to talk about this a. This is a very important point of this scientific notation. A must be contained 1 is less than or equal to a is less than 10. Means a lies in between first 10 digits starting from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You cannot go further. This is the restriction. A must be lies in between 0 to 9. So some people think about that I am saying 0 to 9, but there is written form is 1 to 10. So I need your concentration. The concentration for this equation. This is 1 less than or equal to a. Means the number which is less than 1, it can be 0. So 0, it can be less than or equal to 1. So less than, for less than we can say that this it can be 0, and for the equality we can say that this is 1. So this number starting from 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, because this is less than 10. Less than 10 mean this 10 cannot included in its series, the series of a. The lesser number 9 must be included in it. This is an open statement, open and close statement. So less than 10 mean 10 is not included in this series. The right before 10 number must be included in this. So that's why I am telling you that again and again, A must be contains from 0 to 9 numbers. I hope you will understand it completely. So with the help of example, this is an example. 1.5 times 10 raised to power 8. So 1.5 must contain in this series. This is the first this number is lies in between first 10 digits, that's why 1.5, and 10 must be there, any power which is equal to 8. So this is the scientific notation. Now I am going to solve few questions related to scientific notations. So exercise 3.1, express the following in scientific notation. My first question is 5700. I will write this number in scientific notation form. So first of all I will write 5700 as like this. Now I will write this number in the form of scientific notation, and we also know that in scientific notation first number is any coefficient and the next is 10 raised to power. So I will write 5, and A, you also know that A must be contained in first 10 digits. So for converting it to first 10 digit, I will place point after first non-zero digit. This is the restriction of this equation. 5.700. So for this point I will write 10 raised to power. Now how we can write this power 3. So count the numbers after decimal point. So this is the decimal. After decimal there are 3 digits, so you can write it 3 as a power. So we will write it 5.7, because there is no need to write zeros at the end of the decimal point. So 5.7 times 10 raised to power 3 is my answer. Now my second question is, again we have to convert it into scientific notation. So this is equal to 49 billion 8,000. So this is equal to, first of all we will write it as a coefficient number. So our first coefficient number must contain in first 10 digits. So that's why we will place decimal point right after the first non-zero digit. This is my first non-zero digit, so I will place point right after this. Now 4.980000 and 0. Now I will write 10 raised to power. So I will count the numbers after decimal point. 1 2 3 4 5 6 7. So this is equal to 7. 4.98 times 10 raised to power 7. This is my answer. So my next questions are 960000. I will place point after first non-zero digit. This is the rule of the question. After first non-zero digit you will place a decimal point, and after this 6 3 zeros. Now 10 raised to power, count the numbers 1 2 3 4 5 6. So this is 6. 9.6 times 10 raised to power 6 is my answer. So my next question is 416.9. So 416.9, there is a decimal point already in the question. For each and every question there is a decimal point. In each and every constant number, the decimal point at the end of the number. So we have to shift this decimal point in left side. So from moving to left side, when we move a decimal point to left side, we will write positive sign with the exponent. That's why this 3 is positive, because the decimal point was there at the end of the number. So I will shift that decimal towards left side. So that's why I will write plus sign with this, and also with this, 4.16. Now this decimal point is here, so I will shift again it left side and place this after 4. So 4.169. Now there are 2 points, there are 2 numbers, 1 and 6. I have moved from towards, so that's why I will write plus 2. Next question is 8.3. Then again we have to shift this decimal point in left side. Now look at this. Question number 6, 0.00643. There is a decimal point. Now I will shift this decimal point from left to right. I am moving from right side. I will write it as like this, 6.43. I told you that for each and every first non-zero digit you will place a point. So my first non-zero digit is 6, so I will move this decimal towards right side. So 6.43. Now how many numbers from this? After 6 I will place a decimal, so there are 1, 2 and 3 numbers. So I will write 10 raised to power 3. But this decimal point change its direction. Here right to left, now left to right. So I will place negative number with this. My next question is 0.0074. Now again the same situation, I will place this decimal point after 7. I will write 7.4 times 10 raised to power. I will shift this decimal point from left to right, and in between this 1, 2 and 3 numbers. So I will write minus 3 in it. So this is my answer. Again this is 8.000000, then 10 raised to power. How many zeros are there? 3 and 3 6, plus 1 7. But I will place this decimal from right to left. So I will write 8. There is no need to write these zeros after this number 8, because there is no values on value of these zeros. So I will write 8 times 10 raised to power 7, and this is my answer. My next question is 0.395. So I will place this decimal point towards right side after 3. 3.95, then 10 raised to power 1, 2, 3, 4, 5, 6, 7, 8, 9. So I will write 9, but I will shift this left to right. So I will place negative sign with it. So this is my answer. My next question is in fractional form. So for the fraction I will write 2.75, 10 raised to power 1, 2, 3, 4, 5, and this is 2.5 times 10 raised to power minus 3. So this is my answer. Now question number 2, express in ordinary notation. Ordinary notation means we convert this scientific notation into a simple number form. So we will follow the same rules which we have to use in our question number 1. So now my question is 6 multiplied 10 minus 4. So I will convert it into a simple decimal number. So this is 6. I will write it here. Now this is minus 4. Minus 4 means we will shift a decimal point from right to left, because now I will write a number. So this is 0 point. Now this is 4. So after decimal point there must be 4 numbers. One number is 6, 3 are missing, so I will write 0, 0 and 0. For the ordinary notation, the rules are shifted with each other. In simple number, when we shift this decimal point from left to right, we'll place negative number. But in ordinary notation, when we shift a number from right to left, we will write it as like this. So this was my answer. My next number is again minus 6. First of all, look at this number. This is minus 6. So it means to say that decimal point will place first, then after this these numbers. So there are 6 numbers after the decimal point. 4 numbers are there, 1, 2, 3, 4. Remaining will be, these are 6. So 2 numbers will be remaining. So I will write 0, 0, 9, 0, 1, 8. So this is my answer. My next question is 5.06 times 10 raised to power 10. 10 raised to power 10 mean the number must be written in right side after this. So there are 10 numbers and these are 3. So I will write 506. 2 numbers are these, remaining will be 8. So I will write 8 zeros. So this is the answer of this ordinary notation. Now next question is 7. Again we will write 7, 8, 6, 5 because this is a positive number. So 3 numbers are there, total numbers are 8. 3 are there, remaining are 5. So I will write 5 zeros after this number. So you will write 1, 2, 3, 4, 5, 6, 7, 8. So 8 is there. Now this was our exercise 3.1. Next we have to discuss is its uses of in our daily life. The uses of scientific notation in our daily life.